Hi, my name is Jason Teutsch. I'm the founder of Truebit. I'm going to be talking today about a decentralized pool mining protocol called SmartPool, which we recently deployed on both Ethereum and Ethereum Classic. This is joint work with Loy Liu and Pratik Saxena from the National University of Singapore and Yaron Vellner from the Hebrew University of Jerusalem. So before we get started, I just take a quick moment to direct your attention to the flyers on the tables in front of you. This Truebit is, for those of you who are wondering, is a cryptocurrency initiative which is bringing scalable computation to blockchain. So right now you can run smart contracts on Ethereum. They run for like a fraction of a second and then they stop. So we're trying to make something that runs a bit longer. So that's the goal of the project, and we're looking for all kinds of talent, including people with compiler experience, virtual machine experience, writing smart contract experience, and of course anyone who has worked with WebAssembly is especially welcome to apply for our open positions. So if this sounds interesting, please check us out at truebit.io or come see me after the talk. So let's talk about mining pools. What are miners' role in cryptocurrency? Well, first of all, what's a cryptocurrency? A cryptocurrency is a decentralized network which maintains a permanent public ledger. This ledger is called the blockchain. So, for example, Bitcoin's blockchain contains financial transactions. It's simple. Alice sends 3 Bitcoins to Bob. Ethereum's blockchain, in addition to these sort of financial transactions, also contains stateful programs called smart contracts. So now users can send not only tokens to the smart contract, but also data. So you can interact with it as an input to a program. But who actually executes these programs and maintains their correct operation? Well, that's the miners. So you have these anonymous miners that maintain the integrity of the blockchain in exchange for protocol-generated block rewards. So how do they get the rewards? So there's a mining process. Miners are racing to solve a hard computational problem. And the first miner who successfully solves this problem broadcasts his answer to the network. Okay, and then this miner appends a block of new transactions to the blockchain and receives a block reward. And then this race starts all over again on top of the new block. So what exactly is this problem that they're solving? So we call it the block problem. So you fix some difficulty d greater than or equal to 0. And now the miner has to search for a nonce by randomly guessing random strings such that the hash of the blocks together with the nonce and the data is less than or equal to the difficulty d. So a block satisfying the above properties, we call it valid. Okay, so Bitcoin block rewards as of August 2017 are 12.5 Bitcoins, which is around 43,000 US dollars. And a lot of people like to get 43,000 US dollars. So this means that a lot of people are participating in the network, but only one person in each block is going to get the reward. So the probability that you get the reward, the probability of a given miner finding the next block, is the miner's CPU power divided by the network's total mining power. So more people join, the lower your probability of winning, and the difficulty is adjusted so that new blocks occur on an average every 10 minutes on Bitcoin and about, say, 15 to 20 seconds on Ethereum. Now, an ASIC hardware, which is a specialized hardware for mining on Bitcoin, could take years to mine even a single block. So forget about running your desktop computer at home. That's probably, if you get a block, that's like a once-in-a-lifetime event. Most miners prefer not to have a once-in-a-lifetime event, but some more steady income. So they join hands and form what we call mining pools. So the mining pools, you share CPU power and reward among miners. The mining pool therefore reduces the reward variance and gives people a more steady income. And it increases the security of the underlying network through increased participation. So in that sense, mining pools are really good. So in order to run a mining pool, you have to measure pool members' contributions so that you can pay them for the work they've done searching for the block. So what do? Instead of each person in the pool trying to solve the block problem, they try to solve an easier problem, which we call a share. So a valid share is a solution to the block problem with relaxed difficulty. So it's just like the block problem, but a little easier. So the valid block will say the hash is less than or equal to big D. The valid share, you're less than or equal to little d. So every valid block is a valid share by definition. And the little d over d fraction of valid shares are valid blocks. So some shares are valid blocks, and the pool roughly pays little d over big D block reward per share. So it's fair in the sense that if you count the amount of work you do as the number of hashes that you have to check, the number of nonces you tried, you get paid about the same for mining solo as you would for mining with a pool on average. So that's how it works. So just to recap here, so if you have like you start with your network, Bitcoin or Ethereum. If you're a solo miner, you're just searching for blocks, and when you find them, you send them into the network. If you're running in a pool, then you have a bunch of pool members who are searching for shares. If they find a share, they send it to the pool operator. If that share happens to be a block, then the pool operator sends the block onto the network and then gets the reward and splits it among the pool members. So pool members have to submit shares such that the block rewards are payable to the pool operator. Otherwise, they wouldn't be valid shares. So you're sort of forced to, you can't cheat like that. Now, note that we have a lot of centralization in Bitcoin and Ethereum right now. In fact, 95% of Bitcoin's hash power lies within 10 mining pools. And a similar situation in Ethereum, you got about 80% of Ethereum's hash power in 6 pools. So what's the problem? First of all, there's a censorship problem, right? If you have centralized mining pools, the operators can influence which transactions enter the blockchain because miners choose which transactions clear into the blockchain. And in Ethereum, this is like causes practical problems because people who want to participate in an ICO, they don't get in. So that's one problem. Another issue is that, like in Ethereum, they can control the Ethereum's gas limit. And why would they want to do that? It's so they can inflate the gas prices. Scarce commodity drives the price up. And of course, when you have a small number of these pools, they can also collude with each other. You have a possibility for selfish mining, 51% attack, or any other kinds of things. Other problems. You have single points of failure. There was an Oakland paper earlier this year, Pastalaki, Zohar, and Van Bever found a network partition vulnerability. If you have fewer ISPs that are communicating over the Bitcoin network, this sort of exacerbates the problem. They actually showed that it's possible to partition Bitcoin into 2 separate networks, which is a bad situation if you're trying to keep a consistent blockchain. You also have the issue of geopolitical consolidation. Most of these mining pools take place in China, and so they're kind of maybe the Chinese government can influence them. You also have the social contract. Pool members have to trust their operator to pay fairly for their shares. And as we've seen recently with the inability of Bitcoin to activate SegWit, I mean, you have protocol upgrades, and when you have these large mining pool operator contingencies, it becomes a political game of which upgrades get in or not. And in the case of Bitcoin, nothing gets in. So our solution is let's try to build a decentralized pool operator. So how would you do that? Well, let's first take a step back. Our tools. So what we're going to do is take a so-called smart contract and turn it into a pool operator. So what's a smart contract? Quote from the Ethereum.org. Ethereum is a decentralized platform that runs smart contracts, applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. Okay, so you have users on the network. They can send tokens and data to these smart contracts. Smart contract can send tokens and data back to the user. The smart contract itself consists of a code, in this case written in a language called Solidity, and generated using Solidity. And they have storage where they control the code variables and other relevant data, and they also have a place to store tokens. And the operation of this contract is managed by consensus via the blockchain. So the miners make sure that the smart contracts do exactly what they're supposed to do. So how do we turn a smart contract into a pool operator? So you have the pool itself would have two pieces. You'd have an off-chain piece, which would be the way that the miners sort of interface with the pool, and then you have an on-chain pool smart contract. So the smart contract will check the shares and distribute the funds. So a miner might have multiple machines that he's trying to mine with. So first he requests some work from the pool gateway, and then respond back. The pool gives him some work to do. He submits the work. If there are shares, he submits the shares to the pool smart contract. And then if a block is found, then rewards are distributed to that user's address and everyone else who's participating in the pool. Now we note here also that the miners use the pool's address. It's a Coinbase address in their block, which means that the rewards have to get split among all the users. By the smart contract automates the payment to make sure that those are distributed fairly. Okay, so some of the properties that we're seeing in SmartPool, which sets it apart from traditional mining pools. First of all, we're decentralized. The issues we mentioned before with central point of failure, these sort of go away. And there's the censorship. There's no censorship because the individual miners that participate in the pool can choose their shares. It runs at low cost because, the miners only have to pay Ethereum transaction fees. There's no central choke point taking out a cut here. And you have trustless automatic payouts because the smart contracts basically eliminate social contracts, so it has to pay fairly. And then you have all the usual properties that you'd find in traditional mining pools, like low variance, which is the reason people join the mining pool in the first place, so they can get regular income. It's fair. You get rewards in proportion to the contributions or the amount of CPU power, CPU cycles spent. It's open. You can join or leave at any time. Everyone there is anonymous. It's retrofitting. These are sit on top of existing networks, and you don't need to put a security deposit. You can just switch on a computer and start mining. Okay, so how would we go about building something like this? So the first thing you might try is just substitution. You have your friendly neighborhood pool operator, and you replace him with an Ethereum smart contract. Okay, so what's wrong with this picture? So first of all, the number of shares that you submit in a pool, it's large. I mean, and the Ethereum network can't handle high transaction volume. So the bandwidth is already an issue. Secondly, you have a cost to verify a share on chain because you have to pay the miners to do their work. And actually, the cost of verifying on chain probably exceeds the reward you get from the share. So by mining, you actually generate negative income instead of positive income. So not great. Idea number 2, reduce the number of shares. And this is actually a method that's sort of taken by P2 Pool with their share chain. They adjust the share difficulty so that shares occur once every 30 seconds. And you can apply the same idea to a smart contract-based operator, but this scales very poorly, of course, because the more miners means you have greater payout variance because the difficulty has to get harder and harder each time. Okay, so, and there are other issues if you actually go with the share chain. You have other complications as well. If you have infrequent blocks, this also means a high variance in the payout, and you also get a lot of orphan shares because when you share every 30 seconds, then a lot of people send them at the same time, and then when the network gets 2 at the same time, then one of them gets orphaned, which means that person does not get onto the share chain. And there are some other issues as well that can happen. So finally, number 3, another option you can do is to probabilistically sample shares. And this is actually the approach we take in SmartPool. And we use a sort of we batch the submission. So you get a bunch of shares that you've found. You collect them. You might even put in some bogus shares that are totally wrong. And then the SmartPool is just going to sample one share from this batch of shares. And if it pulls out a good one, then you get paid for all of them. If it pulls out a bad one, you don't get paid at all. And if you do the math, if you put 4 valid shares in, then you get you expect to get 4 rewards back out. So in particular, adding invalid shares to submissions does not change the expected rewards that you get paid out. So it's paying fairly. But we have a problem. What about duplicate shares? Okay, so I'm not going to throw in any invalid shares. I'll just take these 4 shares and copy them over 100 times. And so now I shouldn't get paid 400 shares. What's our solution here to defend against this possible attack is to force miners to actually sort their shares using a new data structure which we call the Augmented Merkle tree. Okay, so what's an Augmented Merkle tree? So let's remember first what's a Merkle tree. Merkle tree is I think is a binary tree where you have at the leaves contain some data points, and the parent of each of these leaves is the hash of its parents, and then the parent every parent is the hash of its children, so that the data at the root is going to force commitment at the leaves. So because it's hard to spoof a path in a Merkle tree because of the inverting the hash. So augmented Merkle tree is similar. Oops. So can everybody still hear me? Okay. So in augmented Merkle tree is you add in an extra bit of information at each of the nodes. So instead of just having the hash of each of the parents, you have also the minimum and the maximum. Yeah, it might be time for a new computer. So thanks. So here you recursively take the minimum of the mins that are above, and you take the max of the maxes above, and that's what an augmented Merkle tree does, all the way down. Okay, and this now you can see that this root actually allows us to witness a sorting error in the tree, because here you have the left guy has a max of 3 and the right guy has a min of 2, so something bad must have happened. So we can sort of witness that. Now finally, a sorted augmented Merkle tree is where you take each of these leaves in the top, and they're now in order from strictly ascending order from left to right. So in SmartPool, our leaves are going to be shares, and the shares batches are ordered by timestamp. So that's the sorting we used on this structure. So how exactly do we submit shares? The protocol goes as follows. The miner first sends the root of the sorted augmented Merkle tree. That's his commitment. That's his batch submission of the shares. So you put all the shares at the leaves, and then you just submit the root. Now the smart contract is going to request one of those leaves. So which is containing a share. He says, I want this leaf. And now the miner has to provide the path to the leaf. So he has to verify the contents of that piece. So that's us checking one out of the whole batch of shares. Okay, so let's see if this works. Let's say how do we catch a sorting error? So for duplicates, remember we're trying to eliminate duplicates in the submission. So in an element X in an array, we say it's out of order. If there's a witness to the left which is greater than or equal to X, or if there's a witness to the right which is less than or equal to X. So if X is 3, here you can see that 2 witnesses that 3 is out of order, 2 witnesses that 3 is out of order, 3 witnesses that 2 is out of order. 4 is actually in order because everything to the left is correct and everything to the right is bigger. And 5 witnesses that it's out of order with itself because you have 2 duplicates here. So this is an array with 4 elements out of order. So how does this impact sorting on the deeper levels of the tree? So for any augmented Merkle tree A, the following are equivalent. Is A is sorted, or for every node in A, the max of X's left parent is less than the min of X's right parent. So, I mean, if we go back to this diagram here where we were, this is just a formalization of what we're seeing in this picture, that the root actually witnesses something that's out of order. And the proof is just the forward direction. You use induction there. So a node which satisfies property 2, we call it valid. So a path from a root to a leaf is valid if all its constituents are valid, and a path which is not valid is invalid. Okay, so let's state this as a theorem. Let A be an augmented Merkle tree. If A is sorted, then all paths in A are valid. That's just what we said on the previous slide. And if A is not sorted, then every leaf which is out of order lies on an invalid path. So the corollary we get is every augmented Merkle tree has at least as many invalid paths as leaves out of order. So in particular, there are at least as many invalid paths as there are duplicate values among the leaves. So in other words, if we sample one path, the chances of us detecting an error are as good as they would be if we were searching for a duplicate. So the sampling technique works in the way that it should. So an attacker has many strategies that it might want to try to do to deviate from this protocol. The obvious thing you always worry about in blockchains is block withholding. And if you sample 2 shares per submission, this is enough to deter rational miners from dropping blocks, because you think that the miner could also be trying to manipulate the random seed for the random sample. So, and rearrangements, it doesn't help to putting the leaves in non-ascending order. Bogus nodes, if you put falsifying nodes in the augmented Merkle tree, doesn't help. And also repeating shares across submissions doesn't help, because we insist that later submissions have to have later timestamps. So if you send in a new batch, everything in the new batch has to have a later timestamp. Okay, so let's look at some implementation details. So the Ethereum has a proof of work puzzle called ETH hash, and it's not it's memory hard rather than just computation hard like in Bitcoin. So it's a little bit of a trick to get this ETH hash mined to be able to get the SmartPool contract to check a proof of work for ETH hash. We also got this piece. We can also build SmartPool so that it operates in Bitcoin. There are some small changes, but you can have a smart contract in Ethereum that's actually operating as an operator for a Bitcoin mining pool. And finally, I'd like to just point out that SmartPool is live. We've been on Ethereum Classic, and we've been on Ethereum. We've mined 86 blocks in June and July 2017, which is about $2,200 per day. SmartPool's running at 0.6% fee. So of all the block rewards that come in, 0.6 are getting spent on gas. And this compares to F2 pool is a traditional centralized pool, which takes 3% fee. So and the number of miners we have up there, there's only 5 people mining. We haven't opened it. It's not open to the public yet, so that's why the hash rate is only like 30 gigahash per second, which is consisting of 200 mining rigs at 6 GPU each. And finally, the Ethereum gas cost per submission is about 2.6 million gas, which follows pretty comfortably within the Ethereum gas limit, which is 6.7 million per block. Okay, and so our project website, we're up at smartpool.io, and of course, I encourage everyone to check us out on Truebit as well. If you're interested in Web3, come talk to me. So thanks very much.
We have plenty of time for questions, so please just come up and use the mics and state your name and then have at it.
Hi, Fan from Cornell. So I'm curious, how do you get randomness from on-chain, basically?
How do we generate the random numbers?
Yeah, in Ethereum.
We just use the nonce from the block hash. So that's why if you block withholding, you could drop the block and get another nonce that comes up But if you getting 2 in a row is not we calculate that it's not profitable to drop 2 blocks in a row if you have less than 50% of the mining power on the network. So that was a calculation we did.
So the nonce from like submitted blocks or from Ethereum blocks?
So Ethereum every block you have a new nonce that comes up. So you just you use that random sequence of bits to determine the shares for. I mean, when the next nonce, when the shares are submitted, then you can use the nonce from the next block to determine which share gets sampled.
Yeah. Okay.
Yeah.
Thank you.
Okay, so we have plenty of time. So just a high-level question. So It seems like one of the things you motivated this was like preventing censorship and these types of things. But what's to prevent someone from starting like an evil pool smart contract that kind of has cooked into it censorship mechanisms in the smart contract that's also doing taking SmartPool and then modifying it to have some like discriminatory treatment of particular blocks?
Well, for one thing, the smart contract would have to be visible to everyone on the network. If someone isn't willing to give you the source code, then you should be skeptical about joining that pool in the first place. But if everyone joined a pool like this, actually, SmartPool is under consideration for the underlying consensus mechanism for Ethereum Classic, so that they actually were thinking about forcing everyone to run SmartPool. So, we're the good guys.
I wasn't trying to imply otherwise.
But I'd just say, like, if someone came along and said, we're creating a smart... First of all, there wasn't even be a mechanism for it. I mean, the smart contract... I mean, who would choose the shares? You would have to, like, hardwire your address in, and it would look kind of weird, but I don't know, maybe somebody would want to do that. They can... could happen.
Okay, since there's no more questions, why don't we thank speaker again?